Okay. It's 8:36. Sorry, guys. Starting a little late. My computer was camera was not working for a little bit, but it seems like we are ready for week two to get started with Intro to Android. So because we're gonna start getting into announcements and stuff, we have a couple of announcements for this week. Let's see. So your first assignment, like a shopping list, has just been released on CMS. There's some rubric information not too important. We will release a feedback form after the assignment submission is done for like an extra sort of 1 point. But that's after the deadline. You don't have to worry about it. The handout for this assignment is on the course textbook. And CMS is how you'll submit your assignments, and there's instructions for how to do that on the course textbook, like the handout or written instructions. And for help, office hours start this week, so you can find that on our ed discussion, like our calendar, as on like an ed announcement pinned. And feel free also to ask questions on ed, and one of the instructors or a TA will respond to you. I guess well, I would pull up the course textbook now, but just in the interest of time, there's a week two. If you open up week two, there's an A2 there, and you can find the handout there. I probably should have put, but this is due on Sunday at 11:59 p.m. Should be relatively quick, and certainly if you come to demo this Wednesday, it should give you a pretty good idea of what to do for this assignment. As a bit of like a heads up, make sure to enroll in this class for credit if you would like to, for up to 2 credits by this Wednesday, because that's the add drop deadline for 7-week courses such as this one. And this is separate from our course application, so make sure to actually fill this out if you want Cornell University credit for this. For some reason, it says Cortland University App Dev. I don't think that's who we are. I think we're Cornell. But okay, so for some very quick FAQ for week one, I had a couple of people ask questions, and I had some people respond on the feedback form about import statements. So I guess just as a heads up, you'll have to import a lot of like code and functions that you write in Kotlin and Android. And whenever you do, sometimes you're given a lot of options, and lots of those options are kind of wrong. Like lots of them are misleading. Make sure in general, if you're trying to write like UI, to import the one that has like a composable annotation, since that is a UI component. And in general, if you're importing stuff like color, stuff like that, then you'll want to import like the compose libraries. And if a function you import isn't really behaving like you expect it, like it's just saying the arguments are not being expected, stuff like that, you might have the wrong import. And so you might want to like undo your import and then see if you can like import the correct one. If you can't import something like altogether, like it just does not recognize it at all, you might be like missing some sort of Gradle dependency, or your Gradle build might have failed-ish. You shouldn't really need to toy with that yet. We'll get into that probably next week, I believe. Quick tip, if you would like Android to automatically import stuff for you, you can go into that screenshot above. We won't do that now. But if you go into like settings, you can go to editor, general, auto import Kotlin, and make it auto import things on the fly, such as if you type .dp, there's only one import for .dp, for example, so it'll automatically import like DP, stuff like that. Nice little quick thing you can do. I figured I should also mention this. Last demo, I ran the app on my physical Android phone. I showed that to you all, but just to clarify, you do not need an Android phone for this course whatsoever. The emulator tooling works very well. It's quite RAM intensive, but hopefully your computer is like okay with that. And so unless we announce otherwise, the default emulator that is just like installed for you in Android Studio, it should probably look like that. Medium Phone API 35 should be all you need for this class and for the hack challenge. Okay, but to get into this week's agenda, so this week we'll start going into states, which start to go into how to make a more dynamically responding UI, how to make your UI respond to changes that the user can like interact with, stuff like that. We'll go into how to organize your UI into components more correctly to make like a better, more intentional code base. And finally, we'll sort of briefly mention LazyLists at the very end, which allow you to show a lot of stuff for in a very organized way and in a very sort of cheap or optimized way in the background in Android. But just to get started, we'll start off with states here. So the idea of like a state is that generally the screens that you're showing will have to show some sort of dynamic data. And by dynamic, that means that by dynamic, I mean that the screen or whatever data you're showing on your screen will have to change and update from moment to moment. And so conceptually, the state, whenever we refer to, I guess, like the state of like a UI or a screen, that conceptually means sort of all of the dynamic data that the UI should be showing. And so not all data really needs like a state representation. So for example, on this like eatery screen, we see that the title here that just says eatery will always say just eatery, right? This text will never display anything different. And so we don't actually need to make like a state representation of it. You can just hard code this string eatery, whatever the text is there. And so states are only needed to tell the UI about sort of dynamic data that can change from moment to moment, say, to respond to something that the user does. And so, for example, here are like a few more clear examples of components that would need to use state. And so this is like a text field. This is a component that's given to you sort of by default in Android as like a library that you can just type text field. And so as the user types in, like if you click on that label, a keyboard will pop up and you can type stuff. And as the user types stuff into the text field, the state of the text must change in order for the actual typed text to show up, right? And same thing's kind of for the slider, where if the user slides the knob, the value, the sort of actual slider visuals must change in order to update with that. And so for these components, in order to make them operate correctly, you'll need to use some sort of state. And so let's see, the conceptual idea with sort of state and like recomposition and stuff in Compose, Jetpack Compose, is that if your screen ever needs to show some sort of dynamic data or data that would change, like information that would change or have to sort of re-render, we represent that with a state in Jetpack Compose. And so state is like a class. There's a class called state and a similar one called mutable state that we will get to in a second. But this is sort of like how Compose works to show and update the UI. And so you can see that if you're familiar with like 2110, for example, this state class has like a type parameter. And basically what that means is that it can wrap any data type, meaning that this state can represent like an integer, double, or really any piece of data that you need to represent. And so if you're like sort of regardless of what kind of data your component needs or your screen needs, whether it be like a number or a string or whatnot, you can make a state to represent any of that data. And so the idea with just like recomposition and all of this like state stuff in general is that Jetpack Compose tries to be like efficient. And so it'll only re-render the UI when in some sense we use this like state flag to explicitly tell it to recompose. And let's see. Basically, state will, or we will use state as developers to tell like Jetpack Compose that a piece of data is sort of critical to the UI changing, and thus whenever we change the state, the screen has to update to reflect that change. And so if you ever have something that is of type like state of t, or like a state variable, a state value, whenever that state changes, the UI will know to update the value. And I guess if you're familiar with like React, like HTML stuff, like web dev stuff, this is the kind of same thing that React does. But nonetheless, whenever a state value changes, that's the sort of flag for Compose to be like, oh, I should be looking after this piece of important information. It changed, and therefore that means I need to re-render. So obviously why the complication is a good question. There are lots of variables just sort of like floating around in memory and in like the Android operating system in general. And if Compose were to just sort of recompose like all the time and sort of re-render that screen every single time there's a variable changing, the UI would be very inefficient since re-rendering is very costly. And so we have to sort of manage our state variables correctly and sort of abide by this like recompose lifecycle in order to like work with this and only cause these re-renders sort of when necessary. Okay, and so mutable state is sort of how you like actually make a state and use it. So you can declare a new state value with the syntax. And so uh, you don't really have to remember too or know what like too much of how this syntax works, but nonetheless, this is an example of how to declare like a string state of initial value Justin and a cost of initial value 1.00. I guess that'll be a double and a string respect or double and a string. And you can use dot value in order to read or write to these states. And so if I say name dot value equals Amy, then that'll take the name value, or that should be a var actually, if I wanted to make that. All right, I don't think it matters actually, because it's mutable state. It will need to be var in a second. But nonetheless, name dot value equals Amy will sort of write to the value. You can sort of reassign the value almost in like a variable sense. And then in your UI, for example, if you want to actually read the value of name, you can use also dot value, the exact same thing, in order to read from that state. And so I guess the idea is if you were to, yeah, okay, this is the next slide. If you were to have a text value that is reading from name.value, if you then reassign name.value at any point, then the UI will correctly know to automatically update the screen whenever that value changes. If you just used a regular string variable that is like var name equals like a string, then the UI actually would not update, which we'll see in a second. It's a bit of like a quick tip-ish. If you're too lazy to keep typing dot value, dot value, dot value, since it seems like, for example, on the slide, why don't I just say name equals Amy and read name? Here's like a little syntax tip you can do in Kotlin. You can use this like by keyword, which it's like really funky how it works in actual syntax, but more or less it'll like under the hood call the dot values for you in order to just like make the variable name appear like a regular variable. And so this effectively converts it into just like a regular variable you can code with, but that will still use state and like UI under the hood in order to do its recomposition stuff, which is nice. But otherwise, if you don't do that, it's also totally fine. As a quick aside, this is like not that important, but you might have seen that we have like two different things, mutable state and state. If you are taking CS 2110 or have taken it, this is kind of the idea of like abstraction. And again, if you're not taking that, it's really not an important thing, but it would just be cool to see if you are taking this class. The idea is that mutable state can be freely changed. Sort of if you have a mutable state reference, you can just sort of keep changing it if you want, versus a state value is just read only, like you can only read from it. This is obviously somewhat counterintuitive. For example, if you could only use state, then why even bother if you can't change it? Because like the whole point of state is that you can change it and then it would cause the UI to update. The idea is that this allows you to enforce like abstraction. So in one layer of your app, it would be changeable, but then you pass it down somewhere else you would not want it to be changeable. Again, not too important. And so for all intents and purposes, until we start diving into like more industry practice stuff, you can just like use mutable state everywhere freely and not have to worry about like the difference between these two. So in any case, you can always just use mutable state for now, and there will be like no difference for now until we get into like the second half of the course. Yeah, okay, so technically in this example, we will not have like states, we'll have mutable states, but it'll work fine. It's the same thing, more or less. Okay. Oops, I was supposed to. Oh, wait, no, that's fine. Okay, so I'll do a quick demo first, and then I'll give some time for questions. But I think I have to change my screen over. Give me 1 second. I should probably just duplicate. Okay, cool. How does the zoom look? Fine. Cool. Nice. Okay. So if this zoom bar will go away for a second, gosh. Okay, cool. So I have a couple of sort of initial demos here just to work out how state works on like a very simple level, and then going into a little bit more of an involved example where I kind of almost build out a screen. But just starting with the simple example here, I have a counter row class or like a component UI component that I'm building. And if you look at the preview, this is super simple component. It's like like bare minimum little counter thing, which is, I guess, just a very simple example of how state works. Just a little button here, or like a row here that says count and then the number of times you've pressed this button, and add, which will hopefully, once we're done, whenever you click add, it will cause the count to go up. And so you can assume anyways that this UI component needs a state variable because the count, the text that we were displaying here, needs some data that updates. And therefore, if we want the component to visually update to the user, we'll need a state in order to tell the component to do that. And so just looking at the code here, we have a mutable state variable that is of like a type integer. We're using by here, again, to just sort of convert like the state to a regular variable under the hood. And I can show you both ways of how to write this, but in the on click here, basically we'll just want to take the state and add one to it. So we can say count plus equals 1. And just simply by that, because the text here is reading from the count variable, if I let it re-render and press add, then all of a sudden the count starts going up. I think something important though to see is, and this is written in the to-do, would this still work if count was not a mutable state of? So let's say, for example, that count, instead of using this like by remember to use a state under the hood, what if we just said it was equal to 0 to start? And so we'll re-render, it'll reset to 0. So even though we're saying count plus equals 1 and reading the count here, whenever we hit add, the count doesn't actually change visually because unless we use a state variable, Compose doesn't know to cause the UI to update. So even though the count variable could, I'm not too sure if it actually does, but even though the count variable like theoretically could be and likely is incrementing in the background, the UI just doesn't know to refresh unless we use a mutable state. And I guess the other way to write it is if you wanted to use just the equals without the by, then, well, there's only two sort of changes you have to make. You can change this to count.value. So this will read with dot value, and then you can do the same thing here. Count.value sort of equals count.value plus 1, and that'll do the exact same thing. Okay, and so if you go here, it'll start incrementing again. And I guess one little note, if you're wondering, this just allows you to like write code in the middle of a string instead of like doing weird concatenation stuff. So like I could just do this too. And it would do the same thing. But this looks a little nicer. So just a nice thing you can do in Kotlin. But yeah, very simple component here. And we can hop on over instead to this a little bit more involved component here. Reminder entry, right? Yeah. So we'll be working through this primarily for the rest of the demos in this lecture. But here we have this little entry where you can sort of enter like a level of importance for a reminder. Enter some text here and then hit add, and then hopefully it'll like populate a list of reminders underneath in this like little mock screen that we're making. The idea is though, right now, I can't actually show the keyboard, but if I just sort of try typing into this text, you'll see that nothing changes. And even though it sort of looks like I am able to type, even if I'm typing on my keyboard, if I'm just passing in sort of nothing for the value, then nothing ends up changing. And I guess the idea is that because this is like, because the text that we're typing into this text field is dynamic data that needs to be changing, we'll need to use like a string state variable in order to cause this text to change. So if we simply sort of, and if I disable my AI autocomplete, if we make a mutable state variable here, let's just say typed text by remember, and then we can make this a mutable state of with the default value of, let's say, nothing. Something to note is that you'll have to spam a bunch of imports to get this to work whenever you write it, which is kind of annoying, but once you do that, it should be good. Then we can use this type text to sort of write to it and read from it. So we'll need to read from it in order to make the text display the right stuff that we've typed in. And then whenever we type new stuff, this on value change will fire to tell us what we just typed in. So we can just sort of write it. It is like the string variable that's passed in here. I can more explicitly write that with like new text that the user has typed in and then pass that in here. So basically, whenever I type in a new text like this sort of function will fire. And with the new text, we'll reset the state variable. And so now if I run this, type some stuff in, and it'll pop up. Okay, so that's just a very basic demo of how to use like state variables uh, let's see, the like very simple like string variables and int variables to show up on the screen. And with that, that's everything for the initial bit of the demo here. So any questions on any of that? And I can also look at the Zoom, but yeah, any questions? Yes.
In the command control that you just set up, where
Yes.
is on value changes?
On value change. Sorry, say it again.
Where is it?
Where is it used? Let's see. Are you saying the function that I'm passing in here, sort of where is it being called?
Yeah.
Good question. So text field is a component that's given to us. So if we wanted to look at the code, there's a lot since it's a very complex component. But if I let this Zoom thing get out of my way, thank you. The idea with on value change is that the like we don't have to look at the implementation because the composed components are already given to us. But the idea with on value change is that whenever I, as like a user of this component, let me try to run it again. Whenever I type into this, whenever I type into the text field here, like whenever I click any of these buttons here, so every time I am typing a new character, this on value change fires every single time. And so the first time that I type it, just like the G, it'll fire on value change with just G. And then the second time I do it, like press R afterwards, it'll fire on value change with the new text being GR. So that's sort of that's at least sort of the functionality of the text field component that's given to us. We don't, because we're using this component and it's already implemented for us, we don't have to worry about like sort of how it's called. The idea is that as a user of text field, like a developer using text fields, we can just say, oh, this is nice. Whenever we type in stuff, this component is implemented for us and it will cause on value change to fire. Does that make sense? Okay, cool. Awesome. Yeah, follow up. Yeah, sure.
We are using like on value change here, but we didn't need to use it in the previous example.
Good question. Yeah, that's a very good question. So the question is why does a text field in general have to use this like pass in a value and then get a new value from on value change versus this component? Oh gosh, this Zoom thing is so annoying. Versus this other component that we wrote has like a state in the component itself. This is just sort of like a decision that you can make for every component. I could have made a component or a row instead that has the exact same thing, like a value int and then just like an on value change that passes a int and returns nothing. This would be the exact same thing. And then instead of having like an internal state, I would just pass the value in here and then say that, oh, the button was clicked. I'm just going to tell the person above me that the value should go up by 1. It would be the exact same thing. It's sort of two different ways to implement the exact same component. And this is actually something we'll go into in week 5. So very good question. But both of those are very valid sort of decisions you can make whenever you're making your component. And both of them have like their pros and cons. Yeah, that decision-making process we'll go over in week 5. But for now, just know that sort of some components will use this design where you sort of let the parent screen do the state stuff, and then other ones will handle the screen or handle the state internally with this like mutable state of call explicitly within the component. Does that make sense? Okay, awesome. Very good question though. Anything else? Probably want to move on since a little winning down the time. But yeah, does that make sense? Okay, cool. In that case, can hop on back to the lecture. So next we'll be going over components and the general idea of like, why do you make components and stuff and what are best practices or some best practices at least. And so the idea with just like components in general or UI components that specifically means I guess as kind of like an analogy, components are to your UI as functions are to the rest of your other coding. And so components are basically like functions that you would know in any other programming languages, but specifically for your UI. And so in that sense, both of them allow you to reuse code, uh, pass in arguments to change that component's functionality, organize your code, and implement like abstraction and stuff if you know CS 2110. So in some sense, they are the same thing just for UI versus like the rest of your code. And so because they are almost the same thing, you can use them for almost the same reasons. And so just to reiterate, if you, for example, want to like organize your code, you can package it into a component and then reuse that component several times in order to like reuse or like reduce code reuse and simplify your code, make it easier to read, all of that. So, I mean, it's technically optional to use UI components, but just like you would make functions in your code, it's probably a good idea to make UI components as well. And so as a quick example, these two eatery cards that you will find on our app eatery are the same component. So they actually would call the exact same component like line eatery card with like open close parentheses. But obviously they display different stuff. They don't look exactly the same. And the way that we will allow that to happen is with arguments. And so, for example, if we wanted to say Max Cafe versus Gimme Coffee, we could have one argument be the title of the eatery that we want to display in that card. Some other things like the location name, sort of everything that you see that differs between the two, we can allow an argument to change the sort of look of that component. And let's see. So in general, for components, you'll want to make like one file per component, just like as an organization tool. It's very useful to see what you're building whenever you're building out a component. And so you can have a preview function in these files that um, allows you to like develop that component within that file. And then afterwards, once you're done with that file, you're done with the component and you can reuse the component afterwards. Um, okay, yeah. So this kind of goes into your question that you had before-ish. But so arguments allow us to send data down into a component. And so if I wanted to pass in the eatery title, I could like pass in a string argument. Same thing for a lot of these other strings. But how would we get user input from a component? So how, for example, if we wanted this component to be able to tell us that, oh, the user just tapped on me, you should do something. How do we do that? That is the idea of like onClick or Lambda functions. So this is very similar to the on value change to that the text field was giving us, or that like an on value change that we could have made in the clicker row if we wanted to. We can pass in an onClick argument or some other like on whatever happened function to the component. The syntax here is kind of funky. And it's like kind of just how Kotlin does like functions. This, for example, this onClick here is a correct like data type declaration for an argument that will take in no arguments because the parentheses are empty and then return nothing. By like if you wanted the function to actually take in arguments, you would say like int comma int if you wanted it to take in two ints, for example, inside the parentheses. But for like most onClicks or all onClicks will have no arguments. And then you'll make sure to like within the function once you pass in this onClick, call it whenever the wherever that or whenever the component is actually clicked. We'll see I believe an example of this soon. But nonetheless, this onClick allows us to like whenever we have a component that we want to tell the parent whenever something is clicked, we can use this onClick so that the parent is notified whenever the component is clicked on. Let's see. What is this talking about? Oh yeah, so this is getting to more like complex conceptual stuff about state. Sometimes when you're developing a component, you'd want the component to like intuitively update with a state. Oftentimes though, you don't actually need to explicitly add a state. This is going very much into your question that you had. The idea is that suppose you wanted the eatery card, for example, like the eatery card will have to change the eatery title You know that it's not always going to say, give me coffee. You know that it at some point will say other things. But you don't actually want to add explicit state to that eatery card because the logic gets complicated. The idea is that you can just take in regular values. So even though the title will change from component to component, you can just take in a regular string. It does not have to be like a state of string. It can just be a regular string. And then outside of the component, you use state values like you normally would to trigger recomposition like of the component itself. So even though the component only takes in a string, it can still recompose because the outer layer uses a state and causes the component then to re-render. And then, yeah, exactly. Your components will naturally update whenever the recomposition lifecycle causes it to update. So any questions about that? Because that's obviously a little bit confusing. And if not, but then we'll hop into the demo to kind of showcase that. But any questions on that conceptual bit? Might be a little confusing. And certainly seeing a demo might help as well. So if there are no questions, we can hop over to a quick demo of how that might look. And so here in our reminder entry, we also have another component here called reminder row that pretty simple. If I see the preview, it'll be even simpler. It's basically just this reminder that can say, oh, either high, low, or medium. And the general idea is, well, you don't have to really know how this works, but we've defined some like predefined stuff, low, medium, or high, that will say either low to green, medium, yellow, red to high, basically just this high, low, medium stuff. And the idea here is that even though the reminders here will say different things, all we have to do for the component very simply is just pass in a title and this like importance value. And note that these are not states that I'm passing in. It's just a regular string, Even though I know that these values will change from different recompositions, I'm just taking in a regular string. And the idea is, well, let's suppose I walk through this to-do two first. So this preview that I'm making, suppose that I wanted this preview to be like an actual kind of functional screen. So let's see, the to-do wants us to, for example, whenever we enter like a new reminder, have a little row pop up. So fair enough. In order to do that, let's make this preview kind of represent like an actual screen. So I'll just make this like a column so that it renders things sort of one after the other so that they don't stack on top of each other. But let's say first that I wanted to be notified if I'm developing the screen that the user has entered some sort of title and actually pressed add. So in order to do that, the screen can't access any of the state variables within the scope of reminder entry since they're within the function. And so in order for me to know that within the screen that the user has like done some stuff, pressed an add button, I need to make an onClick here in the arguments of reminder entry. And so that onClick will look kind of funky. Or I can call it something like on reminder add to be a little bit more useful. This will not just be like a completely empty function, because if you think about it from the screen perspective, the screen will have to render one of these. And so it's going to need a title and an importance. And so we'll need some information in the screen to know what the user has just added. So that can be something like a string for the title and an importance that the sort of this Lambda function will tell the screen that a reminder was just added. So we'll get to see what that means in just a little bit. And I guess the first thing we can do is actually implement this within the function. So we just need to make sure that whenever the user clicks on this add button, that this reminder add is actually called. Otherwise, if I just pass in this argument and never call it within the function, that it'll just never be used. So the idea is whenever this add is clicked, we'll need to take sort of whatever the user has typed in here, whatever the reminder like importance, which is like 0, 1, or 2, which we'll convert into whatever, and actually sort of pass it back up to the screen that is calling it. So in this case, we'll want to say on reminder add. And then just like on reminder add sort of takes in these two parameters, for a string and importance, we'll need to tell it what the user has actually done, like typed in. So the first thing will be the typed text, since that is what we're saying the text field would use to determine what the user has typed. And the second will be sort of the importance value. Again, there's this class that I've made for importance, which just says like, oh, low, medium, or high. As a bit of semantics, you don't really have to know how this works. The slider state will either be like 0, 1, or 2 based off of how I set it up, corresponding, I guess, to low, medium, or high. And so just to like convert that, we can say like when I believe it's slider state dot value is 0, 0f for float. Whenever it's 0, we'll just say it's low importance. Importance dot low. 1f will be oops, importance dot medium, and I guess else we'll just say importance dot high. This is equivalent to just saying like if 0 then low, else if 1, else this. It's just like a more concise way to do it, this like when statement. But you could just use if statements to be the same thing. And then we can pass this in. So this just converts like the 0, 1, 2 of the slider to an actual importance value that the reminder component needs. But you'll see here that if we didn't pass in anything for the onClick, then it'll give us an error. So let's make sure we actually use this value. First thing, we can call like reminder row, the component, to actually render something. And in order for, let's see, how should we do this? I guess I'll make a state variable first of just like a reminder in order to show what it might look like if I didn't use this onClick at all. So let's just say I pass in something that doesn't do anything for now. And let's set up like a state variable so that once the user actually types in something and hits add, the screen can re-render to then show that reminder. So let's just say reminder state. Again, by remember, mutable state of, and let's see. I also have a class here for a reminder that kind of just packages a title and importance into one state, which is nice. So this is a custom class I made. But let's say that if a reminder has been given, we'll actually want to render a row. Otherwise, we'll render nothing. We'll represent that with a nullable reminder. So if it is currently null, that will indicate, oh, the user has not typed in anything yet. Therefore, we should not render any importance or like any reminder. But if they have actually typed in something, then we will render it. So we can just do that with a simple if statement again. So if reminder state is not equal to null, then we'll render an actual reminder with that. And so again, to see the parameters that we need to pass in here, we can just say title equals, or this, we'll just we will rename that to just reminder for concision. Reminder dot title and importance equals reminder dot importance. And why is that bugging? That's weird. Okay, there's like a weird syntax thing there. It should automatically know that reminder is not equal to null, but it seems like we have to assert it for some reason. Don't worry about that too much. But at least if we run this, yeah, at least if we run this, I'll just do this so we can compile. Nothing will actually change even though we've set up this reminder stuff. So even if we go into our component here, type some stuff, make a change here and hit add, nothing will show up because we actually need to set this reminder to the new information that has been given to us by the on reminder add. So on reminder add is firing every time we do this, and it's firing with this type, with the string that we've typed in as well as an importance value, but we're just not using it in the screen. So in the screen, we'll want to change that as well. So essentially, we'll want to take the values here and then update reminder with it. And so that will be a title and like a new importance. And then we'll just set this new reminder equal to like a new object containing those values. And so This again is like anonymous function syntax for saying that this is like the first string variable that has been passed in, and this is the importance like data that has been sent in, which again just corresponds to the fact that we said it'll pass in a string and an importance. And so with this, with sort of both the screen and the component implemented, if we go into here, which should be good, and I can maybe add a little bit to make it a little bit better. If we add like a reminder here, put it to medium and add it, then our grocery renders and pops up because our reminder here has now actually been implemented in the screen. And so the function here will notify the reminder and the row thus will be actually rendered. And the screen will re-render because we're using a state variable. So I know that was kind of a lot. And I guess one little thing before I ask for questions is, say, for example, the user has typed in stuff. We want the grocery to actually like disappear. We could make, for example, types text go to an empty string so that the grocery like text there doesn't lie around. We can say grocery, put it to like medium, and then the types text disappears because we set it to empty string. And just to show that the reminder text is recomposing, we can do something like laundry high importance. And if I hit add, then the reminder row here recomposes and shows the right information now. Okay, yeah, so that might have been a lot. Any questions about either of those steps? So we sort of need to implement this both in the component and the screen. But any questions about any of that or how this stuff works? And I'll also look on Zoom for any questions. But any questions on any of this? Okay, yeah, question. Good question. So the reminder class here is super simple. It's just something called like a data class, which more or less means it's just a very simple class that will just take in some parameters and not really do much. It's just a reminder class that takes in a title and an importance. Oh, by the way, if you downloaded the lecture demo code before, this is something I recently added. So sorry about that. You might need to like re-pull from Git. But in any case, it's super simple class. Basically, all it's doing is just bundling these two pieces of data together, like the name of the reminder and the level of importance. And that this is all it's doing is just saying a title and a importance. And the importance class is like a little bit more funky. I like in hindsight should have told you guys to repoll if you already downloaded the lecture demo code. But essentially what this says is we can have like three importance values, either low, medium, or high, with like a specific color and a text for each of them. But yeah, the idea of the reminder class is simply that it has a title and an importance and then sort of just bundles those two pieces of data together. Does that make sense? Okay, awesome. Good question, though. Any other questions with the code here, since a little convoluted, of course. Any questions with any of that? Okay, and Zoom seems good too. If not, then we will move on from there. Okay. Okay, so very quick aside, I won't even talk about this very much because it's kind of complicated. This is exactly your question that you had before. Sort of how much brain do you want a component to have? You can either choose to put state inside of your component or take it outside of your component. It's a pretty difficult question that like is intricate, so you don't have to like worry about this for now. More or less, we'll just get to this in week 5, so don't worry about it. Okay, so finally, going on to LazyLists. This is pretty like quick, like little introduction to LazyLists. So hopefully we can get it done in 5 minutes. So lazy column and lazy row are very simple components, basically a container that allows you to leverage like a state to efficiently, like very efficiently render even very, very long lists of items. And so they can be vertical or horizontal, depending on if it's a column or a row. And the idea with lazy column and lazy row is that even if you sort of scroll off screen, the content that gets scrolled off screen kind of gets recycled. And so even if you have like an absurd amount of elements, like 9,000 entries in this column. If only four of them are on the screen and all other like 8,000 whatever are off of the screen, only four of them will exist in memory, and therefore only four of them will sort of take up resources to render, and all of the other like 8,000 will, in that sense, be like recycled. And this is as opposed to using like a regular column or row, which will actually, even if they're not visible, like render all of them. And so this is like the very simple uh, code slash usage of a lazy column. The lazy column here kind of uses different syntax in that you don't just call composable functions directly within them. You have to use this weird like item or items syntax. Uh, this is just basically a way for the component itself to know or to like be able to do its recycling stuff in the background. But the idea is you can call item if you want to just make one singular item within that lazy column, or you can call items if you want to like make many repeated items so you don't have to keep calling item, or so that you can make like any arbitrary amount of items. And so the my list here can be like a list of any type, and then for every item within that list, you can render like some sort of UI component, which we'll see an example of in just a second. The idea here, though, is that lazy column uses a state like sort of internally. You don't actually have to write this line of code out every single time, and I think we'll only get to see like a usage of this later on in later demos. But it uses like a scroll state in the background with this like lazy list state. And then if you're using it, you can just use item or items, which we said before. So brief demo of how to use lazy column in the last 3 minutes. Hopefully I don't have to rush through this too much. But you could see here that a kind of failure of the screen that we had just implemented is that you could only have one of them at a time. So if I typed in grocery and wanted to put both of them, it overwrites it because we only have like one reminder row here in this column. And so if we use a lazy column with like a list of reminders instead, we can have like a list start populating through that allows us to put multiple reminders instead. So we can do that by making a lazy column. You can notice that even if you don't pass in a state, remember lazy list is sort of called for you, or remember lazy list state is called for you, but nonetheless, a state is being used sort of in the background to maintain your lazy column. So in order to cause our list here to take in multiple reminders, but let's change the data we're handling here a little bit. So instead of like this state of reminder, which only allows for us to track like one reminder at a time, we'll instead change this to something like a list of reminders. Which can, well, we'll start off just by saying it's a regular list, like an empty list. So instead of using like a reminder that can be null, indicating that there's no reminder, we can use a list to say like we will have any number of reminders as the reminders that we've typed in so far. So I can say reminders just for clarity. So we can delete this stuff. And so don't worry too much about the syntax I'm about to write. It's kind of funky. So we'll make a new reminder just as like a little variable here for a second. So this just basically does the same thing we were doing before. We'll make a new list from basically what our list is before, appended with like this new one that we just made. This is like really weird that you can do this in Kotlin. You can literally just do plus and it'll like append it. But it didn't actually mutate the list. You can think of this as basically taking like reading what the old value was, just like returning a copy of it, and then you append it, say this is like the new list, but you still have to like assign it. So I'll say reminders equals new list. I'm pretty sure you could also just say reminders plus equals new reminder. This probably works because of the by keyword. That makes it almost just behave like a regular variable. We'll see if that doesn't work, and if not, we can change it back. But the idea is that if instead we pass the reminders in here as like items to this lazy column, and say that the reminder here will be passed in. This is like kind of annoying. You have to import this, but it like doesn't give you a big red underline. If you want to use this like item syntax, you have to import that. It's really annoying. But If we call a reminder row here with this new reminder we've passed in, basically just the same stuff we were doing before. Then now we can render like a bunch of reminders in sequence in this like lazy column. So I think I did this right. So let's test it. If I say grocery, add pops up. And if I do laundry, change the importance to like medium, add, then it shows up in the list. And I can say, what else? Pay bills. Very high importance because otherwise I'll be evicted. Then say hi. And all of them will sort of populate in this list. Um, and I guess if I wanted them to populate in the reverse order, I'd probably want that other syntax to then like add it to the front instead. But nonetheless, this allows us to render all of these in a list. And if I were to add so many that I'd start scrolling, I guess I can, well, I can add empty ones just for demo. Pretend I typed something important there. Then you can see I can already start scrolling through them, since that's sort of like functionality that the lazy column already gives me. The preview is really laggy, so don't worry about that. But nonetheless, this allows us to add a bunch of them, and I even have like automatic scrolling functionality since that's something lazy column provides us with that like state. But I know that was kind of a lot, and I am actually over time, so I'll just flash the attendance here for a second, so you all are free to go. But of course, if there are any questions, feel free to ask with that or just indicate it on the feedback form, since that was relatively fast paced. Or feel free to stay after class as well to ask us questions directly. And that also goes to people on the Zoom. But if you have no questions, no other questions, then that's all we have for lecture for this week. And if that all seems like a good amount to you, kind of new stuff, don't worry, we will go over very much implementing this yourself on Wednesday as well. So thank you very much for coming, and that is all we have for you today.